In this short video, we are going to take a closer look at a brand new ARW-Misure product. Specifically, we are going to look at the ARW-159 Coating Thickness Gauge. The instrument, as we can see, comes inside its own sturdy protective box. This package includes a durable ABS carrying case. Inside this ABS carrying case, we find the instrument itself, which is a high-precision thickness gauge featuring an integrated probe system that enables direct contact with the surface, along with its detailed user manual, a set of precision calibration foils, and the essential zeroing bases. This version here is an FN version, so it's for ferrous and non-ferrous materials, magnetic and non-magnetic substrates. It comes with two zeroing bases, one made of magnetic iron and one made of non-magnetic aluminum. Completing the kit, there is a USB cable. The USB cable is used to connect the device to the PC for data transfer. The device comes with software included. In fact, there is also a USB stick that allows us to install the software directly onto the PC. We can also find it on the product page, which we will look at the end directly on the website, and there is the option to download it. Now let's go into more detail and take a look at the features and functionalities of this device. Let's proceed by turning on the device. The very first thing you will notice is definitely the impressively large color LCD display. It's a graphic display that allows us to keep everything under control. The first screen already provides us with the option to use the FE/NFE measurement mode, which allows us to understand what type of substrate we are currently checking, whether it's magnetic, ferrous, or non-magnetic, as well as the time, and the remaining battery level displayed in the center. We have the measurement we are performing, and below that we have the data stored in memory. In this case, we see G1, N12, which means group 1, 12th reading saved in the group. We will later see how the memory function works. In the central part, we find the data statistics. The data statistics allow us to see the maximum and minimum levels, standard deviation, and average value, which are clearly updated continuously as we take measurements. An interesting feature is that this instrument, as we can see in the lower part, also gives me environmental values for temperature and humidity. The sensor is located on the back. The data that we collect are specifically related to the surrounding environment and not to the material itself or to the probe that is being used. And clearly, if we hold it in our hands, the readings may be slightly affected by the temperature of our hands. Therefore, if we want to measure temperature and humidity, we need to place it and let it stabilize in the environment without holding it in our hands. Then we will see that we also have the possibility to change these settings here. Now let's take a look at the Instruments menu and analyze its various functions. To enter the menu, as we can see from the keyboard below, we have two function buttons, one red and one blue. The red button also serves as the power on and off switch. And then we have two arrow positioning buttons used to navigate the options within the menu or to configure and set any data values. Let's press it. The red button, and we enter the function menu. As we can see, the first mode is the operational mode setting. Within this menu, we have the possibility to select and set the operational mode. In fact, here there are two distinct operational modes available, group mode and SSPC mode. SSPC is an organization that regulates a specific type of measurement. That is, to put it simply, which is a concept we will examine in greater detail later on, it calculates a precise average per area. We set the points we want. For each area, the number of areas, and the instrument calculates the average of those points for each area. We will also look at the visualization later. Meanwhile, the group mode allows us to measure either directly, saving the data to the various groups we have selected, or to take a direct measurement without saving any data. Looking now at the settings menu, and here we look at the group mode, you will notice that we have the specific possibility to select up to 50 groups with a maximum of 50 data points and 50 individual values within each. What does this mean? It means that the data memory allows us to measure up to 50 different groups, so files, and within each 50 values. Here we have, for example, group 1 with 12 values, group 2 with 50, so it's full, and group 3 with 9 values. If we fill up the memory with 50 values, the device prompts us to change and switch the group. If we go up, we see the direct mode. In the direct measurement mode, we measure without saving the data anywhere and without using different modes. This can be, for example, the SSPC standards, which stands for the Society for Protective Coatings, and this specifically allows us to perform exactly that type of measurement process for our needs. There. We will be a company that, let's say that in that case, consideration is given to the cleanliness and imperfections of the underlying surface. That's why different areas are selected and multiple points are measured in each area to average out any imperfections. When you are in the SSPC mode, you actually manually set the specific number of points per area. Now, what exactly does that mean in practice? In this case, I have set it to 3, so I will take 3 separate measurements. And the instrument calculates the average of those 3 measurements and records the data for that specific point, for that specific area. In fact, we have the option to set the number of areas with a minimum of 5 areas in which 3 points are measured per area, and the average of those 3 points is calculated. We'll also look at this during the measurement process. The last option is delete memories. Delete memories clearly allows you to reset all the stored groups we have saved. Now, let us move on to the next submenu. This next submenu is where we can specifically choose the measurement modes, such as FE, NFE, or even both, depending on your needs. FE works only on ferrous materials, substrates, ferrous-magnetic, NFE only on non-magnetic materials such as aluminum and stainless steel. Both means that the instrument automatically recognizes the substrate and adapts the measurement depending on whether it is magnetic or non-magnetic. This is interesting perhaps also to check what type of substrate we have. Generally, you always leave it on substrate unless you want to specifically work with or identify a particular type of substrate. Let's move on to the next one, unit of measurement. What do we have here? Microns, mils, millimeters, and inches. Micron clearly 1/1000th of a millimeter and 1/1000th of an inch. We can reduce the resolution by setting it to millimeters and inches. Next step, environment. This is the well-known setting that allows us to display the temperature and humidity at the bottom of the display, as we saw on the main screen. Here we have the option to set only temperature and humidity, temperature and dew point, which is the dew point, the condensation point, as we might call it, or we can choose not to highlight anything, which means that nothing will be displayed. On the display, no data will be shown on the screen. Here we also have the option to choose the unit of measurement. For temperature, either degrees Fahrenheit or degrees Celsius. The calibration process. Calibration provides us with the ability to use several modes, including mode 0. This lets us calibrate based on alignment or on a specific sample piece. In the case of high robustness, it is still highly recommended to perform the 0 calibration directly on the piece on the substrate, which is clearly not coated at all. Next, we have the single point measurement mode. In this case, we proceed to carry out the procedure. It then instructs us to perform the 0 calibration process. For example, if we take a reading in this mode, we press the OK button and we see that it asks us to place the device on the base plate provided. Okay. We confirm by pressing OK. It asks us to place a thickness gauge. In this case, we set it to 101. The reading is 107. After measuring, we simply press the button right here, and it prompts us to change the value, to set the value of 101 for the process sample. We use the arrow keys. Okay, 101.1, but in any case, we press OK. In this case, we have completed the calibration. If we proceed to measure, as we can see, we have a red alarm, which is the specific limit setting configuration that we will see later. This is the standard single point calibration mode. The SSPC mode, which is an essential part of this specific regulatory body. A multi-point measurement over an area allows us to select and perform a calibration at either 1 point or 2 points. Here, the base calibration is intentionally omitted from this process. Because we perform a calibration from a minimum value to a maximum value, focused exclusively on the coating layer itself. In most situations, meaning over 90%, the calibration that will be performed will always and only be at the single point level. The reset function allows us to completely restore the factory calibration values, returning it to the original default settings. Here we find the well-known limits that are used to determine the acoustic signal, and the LED, which can be green or red, depending on whether the limits are exceeded or remain within the limits. In this menu, we have the convenient option to either enable or disable the limits and fully configure the display settings. For example, if we want to have the display notifications through the flash, the LED light, or the buzzer, which acts as the acoustic signal, we can choose to have both of them active, just one, or even neither of the two. Here, we set the high and low values for the limits. In this case, a high value of 100 micro was set. In fact, we measured 101 and the red signal turned on. And the low value, which in this case is set to 0. Here, we set the range that we want to be signaled as an alarm. The very last item that you will find in the main menu is the settings section. This is where we can configure all of the various instrument settings, from the display rotation, which is one of the most interesting features of this device, and we'll see it during measurement, to the key beep, which is the sound signal when pressing the buttons, and even performing various diagnostic tests of the system. The concepts of stability and continuous testing. These two elements work together seamlessly. Let's look at the continuous mode. This essentially means that I have set up a specialized system that allows me to manually drag the instrument across the entire surface and instantly observe the real-time variation in the data. It is a thorough, continuous measurement process that we could say is effectively done by dragging the sensor. A very important thing is that clearly, if we have a surface, if the surface is rough, we could end up damaging the sensor. So please make sure it is a painted surface and in any case, very smooth, without any imperfections or visible flaws. The stability test feature is enabled and works only when a specific S signal appears on the display while in continuous mode, because it allows us to, at the moment when we perform, dragging and sliding the instrument over the surface of the probe of the sensor serves to check the stability of the instrument. So, when we turn on the setting for continuous measurement, we also automatically enable the continuity test. The wake-up feature simply refers to the setting for the date and the shutdown time. In this specific menu, for the shutdown time, we have options for 30 seconds, 1 minute, 5 minutes, or disabled, which is how it is currently set right here. Time is the setting for the hour. The brightness setting lets us adjust the contrast and the overall visibility of the display. Language lets us select the menu language. We have selected Italian, but as we can see, there are quite a few languages, including English, French, Spanish, and Portuguese. Pretty much all of them are available. The final element on our list today, which is not something you manually set or change, is the welcome message, which is automatically configured as the standard default setting. Furthermore, as we previously discussed in the earlier section, the display can be easily rotated, allowing us to turn it a complete 360-degree rotation. It even works perfectly when held completely upside down. This feature can definitely be very convenient for various types of measurements where, since the probe is already built into the unit, we might frequently need to adjust our position or reach into tight spaces. You can take readings directly upside down and thus have a perfectly correct view of the display, even in very awkward positions. Now let's take a detailed look at the SSPC measurement mode and the group measurement mode. In this specific case, as we can clearly see, it says direct right here on the screen. If we go into the main menu and then navigate directly to the specific mode by setting the option to group, which is fine, and then we are going to select the specific group of items and not do it directly. Let's choose group 3, which still has 9 readings. Okay, we'll see that on the primary display screen, it clearly indicates G3 number 9. There are already 9 separate recorded readings. If we continue forward with the next measurement, we have already taken 3 readings, and now we have a total of 12 readings to analyze, still with group 3. As we go deeper inside the group and select group 3, we also have the option to view all the measurements we've taken. From here, we can also transfer them, as we will see in another section. We'll also see how to transfer them directly to a PC using the provided software. The SSPC mode, on the other hand, allows us to perform a more detailed analysis. Now that we have set 3 specific readings, 3 distinct points, and 5 separate areas, we can proceed. Once we select the SSPC mode and ensure it is fully configured, if we navigate back to the main screen, we will notice that the display layout has changed significantly. It shows us the data directly. In this case, some readings have already been recorded. We can clearly see S1 and S2, which represent the specific areas we are monitoring. And right here on the screen, we have the average of the values we have recorded so far. Essentially, we calculate a new area for every 3 readings we collect, since 3 points are required to define it. In this scenario, we first take a set of 3 readings, and then we follow that by taking another set of 3 readings to continue the sequence. And every single time we take 3 data readings, we'll have the next area ready. If we complete the measurement, as soon as we have finished the measurement, all 3 of these areas will be fully completed. In this case, we are seeing a red warning signal because, having set the limits at 100 micro, we have basically exceeded those established limits. This system allows us to take measurements at multiple points per area, so we can identify the areas we want to measure and set the points per area on which we want to calculate the average level. That concludes our detailed explanation regarding the various features and functions of the ARW-159 Coating Thickness Gauge. For more comprehensive information or to purchase this instrument, you can visit our official website at ARWMisure.it. Once you are on the site, you can simply enter the model number 159. And here you have the possibility to find the instrument directly, including all the specific features, the technical data sheet, any available video links, and all the detailed information. You also have the option to directly download the software or program from the product page. For any decisions, please also refer to the titles shown in this video or in the description. Thank you for your attention, and see you next time.